fingers at home position and change to Chrome. Hello. Thank you for watching this last video of my sequence of videos for this Friday. If I'm dating the video, that'd be weird. Now, here we go. Let's go back and take a look at the question, right? This is for naming or listing the isometries that describe the sequence of isometries that shows the two figures are congruent. I mean, if you don't know what isometries are, it's already in the sentence. But you could go Google. Hey, Google, define isometries. Not a sponsor. Isometry. It's a mapping of a metric space onto another or onto itself so that the distance between any 2 points in the original space is the... Well, I ran out of definitions, but take a look over here. I opened up a Google image. Just clicked on Google image. Zoom. Is an isometry. The image over here moved over there, and it's the exact same size. Isometry. Then there's a reflection. A reflection, it flipped over the line, even though it's angled one way and now angled the other. The size of, that's a solid gleek. The size of the shape is a rotation. It's like we actually like turned it, and then a dilation, not an isometry. Dilations are not isometries, but they are cool transformations. Draw and describe the sequence of isometries that shows the two figures are congruent. I mean, you kind of got to just guess and check a little bit. So by guessing and checking, I've got the original, the OG triangle, because it's just letters, no apostrophes, primes, they say. And if I take this and I slide it, that didn't work. I rotate it. Well, it almost works. I got A and A prime to line up, but this is B prime and this is C. So a rotation doesn't quite work. Could I do I guess, let's see, translation, slide. Doesn't work. Rotation, turn it. I mean, it looks like it works, but the fact that the letters don't line up, that'll cost you points because it's not a rotation. A reflection, let's flip it. Let's flip it on a different angle than horizontally. Let's flip it like this. That might do it. You know what? It might be just one reflection, but now I got to let you in on a little secret. Here's the first thing. You should, well, first of all, you remember the trick with the stuff? You got to take the paper, you got to trace on the other side of the tracing paper to leave a graphite imprint wherever you go. Okay, pig pen from Charlie Brown, that sort of style. Okay, by the way, I traced it, so it's going to do that, but down here. Now, this is probably the first one you should do, okay? So I'm gonna let you in on this little secret. I wonder if I can slide directly up to there. That's pretty doggone close. In fact, I'm going to say, like, there might be a little bit of a motion that needs to happen. Like, are these lines actually parallel? But if I slide, so you got to name the proper transformation name. If I slide this over, and then somehow I imagine like a action like that. Did you see it? Did you miss it? An action like that will happen. Probably only need to list two things. Literally though, ladies and gentlemen, or whoever else is watching, slide is probably the first thing you should do, and we should probably slide A to A prime. And then, I mean, it might need a little teeny tiny rotation, just a teeniest of tiniest rotations, just a little one, just to make C and C prime like line up. So maybe a rotation centered at A by just enough degrees to make C go to C prime, and then reflection over the line AC, A prime, C prime. I mean, I said it, I'm not writing it, so here it is. First you do a translation from A to A prime of the triangle ABC. Then you do a rotation of the triangle ABC centered at A prime so that C goes to C prime. And then you do a reflection over the line A prime, C prime so that triangle ABC goes to triangle A prime, B prime, C prime. Thank you and good day.